Hello, today we'll be doing number 44, which is find the integral from 2 to infinity of 1 over x plus 3 times x plus 1 squared dx, or state that it diverges. And as much as I'd just like to state that it diverges, it doesn't, and we'll see why. So just straight off the bat, you have 1 over linear factors. So this looks like a job for partial fraction decomposition. And with linear factors, that's going to be a constant in the numerator for each linear factor. And we count repeated linear factors as 2 different factors. So you have a over x plus 3 plus b over x plus 1 plus c over x plus 1 squared equals this 1 over this. So now we multiply out by x plus 1 squared times x plus 3 to cancel all the denominators, which gives you a times x plus 1 squared plus b times x plus 1 times x plus 3 plus c times x plus 3 equals 1. So you can zero some factors here by substituting by substituting specific values of x. So let's first substitute x equals -1. And that cancels out the a term because you have -1 plus 1 squared, that's going to be 0. It cancels out the b term because you have b times -1 plus 1, which is going to be 0. And now we're just left with the c term. C times -1 plus 3 equals 1. C times 2 equals 1. C equals 1/2. And now we'll substitute x equals -3. So that cancels out our b term, right? Because you have b times -3 plus 1 times -3 plus 3, that's 0. And that cancels out our c term, because then you have c times -3 plus 3 equals 0. So we're actually just left with a times -3 plus 1, that's going to be -2 squared, equals 1. And the quantity of -2 squared is 4. So 4 times a equals 1. A equals 1/4. Okay, as I was saying, now we solved for a. And the shortest way to solve for b is you're going to have, if you multiply this out, you're going to have a times, you're going to have an ax squared term, right? Because you have times the quantity of x plus 1 squared. It's going to be ax squared plus 2ax plus a if you completely expand it. But what's important is you have an ax squared term. And if you expand it, you're going to have a bx squared term, because you're going to have bx squared plus 4x plus 3. But again, what's important is that we have a bx squared term. And there's not going to be a cx squared term because c only has one factor that is multiplied by it. So you have ax squared plus bx squared. And on the right-hand side, there's actually no x squared. So what that means is that ax squared plus bx squared equals 0 x squared. Therefore, a plus b equals 0, and b equals -a. And since we already solved for a, we'll just substitute b equals -1/4. All right, now we're ready to integrate. So we rewrite it as I equals integral from 2 to infinity of 1/4 over x plus 3 minus 1/4 over x plus 1 plus 1/2 over x plus 1 squared dx. So these integrals are pretty straightforward. You have ln, the integral of x plus 3, of 1 over x plus 3 is ln, absolute value of x plus 3. And the integral of 1 over x plus 1 is the absolute value of ln of the absolute value of x plus 1. So the only different one here is the integral of basically 1 over x squared. And you recognize that that's x to the negative second power. So the integral of that is just going to be negative x to the negative first power. So now we just have 1/4 ln absolute value of x plus 3 minus 1/4 ln absolute value of x plus 1 plus 1/2 times negative x to the negative 1. And let's just rewrite that last term as minus 1 over 2x. So let's basically evaluate at infinity. Just plug in. What you could do is put in r and then take the limit as r goes to infinity, but I feel that in this case it's pretty simple. You have 1/4 ln absolute value of infinity plus 3. So as you go to infinity, constants kind of become irrelevant. I mean, added and subtracted constants. So you have 1/4 times ln of the absolute value of infinity, and that's just going to be an infinite quantity. Minus 1/4 ln absolute value of x plus 1, also an infinite quantity, minus 1 over 2 infinity. And that's just going to be 0. So this may look troublesome, actually, but what you can do is use properties of logs to rewrite this as 1/4 times ln of absolute value of x plus 3 over x plus 1. Right? And what that actually allows us to do is simplify 1/4 ln, well, x plus 3 over x plus 1. That's actually 1 plus 2 over x plus 1. It's kind of simple polynomial division. So now if we put in infinity, this 2 over infinity term tends to 0, and we have 1/4 ln 1, which is 0. So this entire first evaluation at infinity is 0. So that leaves our evaluation at 2. So you have 1/4. Let's just use our shortcut. ln absolute value of 2 plus 3 over 2 plus 1. That's going to be 5/3. minus 1 sixth. Except you have to remember that what you're doing is when you're integrating, when you're doing a definite integral, you're saying the evaluation at b, if you're integrating from a to b, minus the evaluation at a equals the area in between. So this is actually all negative because our upper limit, our upper bound is infinity. So because this is our lower bound, we're subtracting all of this. So if you negate all of this, you end up with our answer 1/6 minus 1/4 ln absolute value 5/3. That's just ln 5/3. You could also simplify that to 1/6 minus ln 4th root of 5/3 if you wanted to. So, just a summary, we used partial fraction decomposition, we integrated, and then we took the limit as r went to infinity. Okay, this was a long one, but I hope it helps.